SPIE presents the Advancing the Laser series, honoring 50 years of laser achievements.
My name is Martin Richardson. We're here at the College of Optics and Photonics at the University of Central Florida. And I also serve as the director of the new Towns Laser Institute that was created here some 3 years ago. I've been here in Florida for nigh on 20 years now. Obviously don't speak with a Floridan accent. I was educated at Imperial College in London many years ago. Right at the beginning of the laser age, I had the good fortune to spend an hour one afternoon with Professor Towns in his office at Berkeley. He hadn't long been there after moving from MIT. And what I found so gracious in him at that time was his willingness to sit there and talk lasers and science with someone who he really had never known before, who was just starting out on a career, as it turns out, a career in lasers. And to give me a sense of how big science was and the benefits there could be to mankind and the like. This bigger glorified picture, if you might like the sense. And I've never forgotten that. So for this reason, it's been extremely pleasant for me to have input into creating of a new laser institute that he's graciously agreed to have his name associated with. A laser institute that I hope will become the predominant academic institute in lasers in the country and worthy of his name behind it. What you see here is an illustration of one of the projects that we have here in the Towns Laser Institute. This is, although it looks very complicated, this is really the gist of the next generation of ultra-short laser systems. This is Michael Hemmer, who is the architect of this laser system, has been working on it for his graduate degree for the last few years. He's not far now from finishing, and has built most of this complete lasers, built and designed most of this laser system. So it shoots out a laser pulse that's only 4 or 5 femtoseconds in duration, which gets amplified up to the multi-millijoule level at the 10 to 20 kilohertz repetition rate regime. So a laser system that will be the successor of the currently commercial Ti-Sapphire based high-intensity laser systems. This is another example of how we bring lasers to have impact economically. This facility is our principal facility for making EUV light using laser-produced plasmas. 2 of the graduate students currently working on this program are Vani Kamtaprasad, who's working on the spectroscopy of these light sources, and Omar Rodriguez, who is working on the lasers that are used to illuminate these sources here. Here we are making laser-produced plasmas at a high repetition rate inside this vacuum vessel. The laser comes in from the right-hand side here, and that's close by Omar here. This laser light is not on, so nobody has to wear the goggles at the moment. But it comes into this chamber. In fact, 2 beams will come into this chamber and illuminates droplets, high-speed droplets, liquid aerosol droplets in the center of the chamber here. And you can see some green light in the chamber. On the video screen here, you see the formation of these droplets. These are droplets about 30 microns or so in diameter, having multi-constituent chemical constituency, including the metal tin. And we have found, after much experimentation, that tin is the best material to produce laser plasmas, specifically laser plasmas that produce EUV emission at 13.5 nanometers. This is a very important wavelength for, believe it or not, the chip industry. Since the next generation of chip manufacturer is most likely to be EUV lithography using light sources like this for printing computer chips, the next generation of computer chips, going down to minimum feature sizes beyond 22 nanometers in scale. Today, in this period of time, I see more excitement in the laser field and more potential for the future of lasers than perhaps at any time in the last 50 years. I think we're rapidly moving towards thinking of lasers as, rather than complicated multi-component devices, to being monoblock light engines of the future.